Hello my dears, how are you all? So in the last class we derived the equivalent circuit referred to primary as well as secondary of a transformer, and now we have to see what is the exact equivalent circuit of a transformer. Exact equivalent circuit of a transformer. Exact equivalent circuit of a transformer. What is the exact equivalent circuit of a transformer? Exact equivalent circuit of a transformer. So what is the meaning of that exact equivalent circuit is that exact means you have to simplify the circuit to maximum level, that is meaning of exact equivalent circuit. So in the transformer you have primary as well as secondary. There is a shunt branch in the primary, right? That R omega and J X omega, or that R plus J XM, right? R plus J or RW plus JX. So that shunt branch, normally the value of I0 is, I already told you that 2 to 5% of IFL. IFL is nothing but the full load current. So the value of I0, since the value of I0 is very small, you can shift the shunt branch before the series branch. That means you can make the arrangement like, you can directly place your shunt branch here. You can directly place your shunt branch before the series branch. So this is R2 and this is JX2, and this is R1 and this is JX1 and JXM and RW, and this is IM and this is IW, and this is I0, and this is nothing but I1. This is something I1 and this is nothing but I1 dash. This is nothing but I1 dash, and this is nothing but V1. And if you transfer this resistance from secondary to primary, because it is electrically isolated, right? It is just magnetically connected, but electrically it is isolated. And also this I0 is very small, and also this RM is also very small. Since the I0 is very small when compared to this I1, we can neglect this branch. Like, no, this is likely to be open circuit condition from this to this, because value of current will be 0.5, 0.8, 0.9 range. 0.5, 0.5 or 0.6 range the current will be. So due to the small value of current, you can again reduce our circuit in the sense, reduce our equivalent circuit to what? Simply, and you can take the secondary side impedance and voltages to the primary side, so that it will become whole dash, right? Correct? This is I2, right? So this will be R1, this will be JX1, and this will be V1, this will be I1. So you can reduce our circuit like this. That means simply we did one thing. We did what? We took the secondary side resistances, voltages and current, which can be used to what? Which is represent now in the form of what? Referred to primary side. But then what is the value of this R2 dash? You know this. Suppose this is N1 and this is N2, or this is E1 and this is E2 means, how can we find the value of R2 dash? R2 dash is nothing but, we have to make it to, or we have to take that from secondary to primary. So 2 what? That will be the numerator, right? So it will be N1 by N2 the whole square into old one, that is old R2, and x2 dash is nothing but similar n1 by n2 the whole square into what, old x2, right, old x2, and I2 dash is nothing but what is that, n2 by n1 bus, n2 by n1 into old I2, correct. The reverse will be in the case of I2. I already told you this, right, I already told you this, and V2 dash will be equal to V2 into what n1 by n2, correct, n1 by n2. So this will be the value of corresponding values of V1, V2, V2 dash and R2 dash and JX2 dash. So now you have, see, this R1 and R2 dash in series again. So you can again reduce this circuit to, what? See, bus. Simply you reduce this, so this I1 will be this also, right? So no need to, in this diagram, okay, I1 dash, if you remove this means there will not be any I0, right? So this I1 will be simply I1 dash, and that I1 will be equal to, I1 dash will be again equal to I2 dash. So I can write like this, I1 will be equal to simply I2 dash, and this R equivalent, J equivalent and V1, and say this I1, okay, and this R equivalent dash is nothing but R1 plus R2 dash. X equivalent dash is nothing plus X1 plus X2 dash plus. So this is the exact equivalent representation of, finally what you get from a transformer. What is the essence of a transformer? My dears, what is the essence of a transformer? And this is the essence. This is nothing but a series RL circuit. So transformer is essentially what? Essentially it is a series RL circuit bus. Transformer is essentially a series RL circuit. A series RL circuit. Is it clear? Is it clear, my dears? Okay. So that's all about the exact equivalent circuit, and we will do some more problems regarding the transformation. That's very important. That's very important. By the view of numerical, the chances of asking questions from this session is from the conversion. What will be the resistance referred to secondary, referred to primary, reactance referred to secondary, reactance referred to primary, like that. Okay, that type of question maybe you may expect. So let's do some more problem regarding that, and applying this concept also there. Okay, applying the concept also there, so that we will have a grip on that area, right? We'll have a grip on that area. We will have a grip on that area. Okay, write a question. In a single phase transformer of 660 bar 220 volt, if secondary winding have a resistance of, if secondary winding have a resistance of 5 ohm and primary winding have primary winding having again here also having a resistance of 5 ohm If a secondary winding having a resistance of 5 ohm, if a secondary winding having a resistance of 5 ohm and primary winding having a resistance of 5 ohm, and primary has a reactance of 3 ohm. If the secondary winding having a resistance of 5 ohm and the primary winding having reactance of 3 ohm, and primary winding having reactance of 3 ohm. Reactance of 3 ohm. Okay. Find the resistance and reactance referred to primary. Find the resistance and reactance referred to primary. See the question. In a single phase transformer 660/220 volt, if secondary winding having a resistance of 5 ohm, okay, and primary winding has a reactance of 3 ohm, find the resistance and reactance referred to primary, right? Primary. N1 by N2 is equal to what? 660 divided by 220. There is any doubt that? There is any doubt in that? It is nothing but 3 by 11, right? So it is nothing but 3. So N1 by N2 is nothing but 3. So we have to find, see, if the secondary winding having a resistance of 5 ohm, that is simply R2 equal to 5 ohm, right? R2 equal to 5 ohm, and primary winding having a reactance of 3 ohm, that means X1 is equal to what? 3 ohm. We have to find the resistance and the reactance referred to primary, we have to find. Okay, let's find that. So listen, so what will be the resistance referred to primary? Resistance referred to primary means, if the R2 is 5 ohm, when is referred to primary means, what will be the new value of resistance, which is nothing but R2 dash, right? R2 is in the secondary side, right? It has to come to primary, so that resultant resistance will become R2 dash. I already told you that R2 dash is nothing but old R2 into, to which area it is coming? To which area it is coming? To N1 area it is coming, right? To primary it is coming now. So to N1 area it is coming, it will become, or to N1 side, area in the sense N1 side, okay? So R2 into N1 by N2, the whole square, which is nothing but, R2 is nothing but 5 and N1 by N2 is nothing but what? 3 square. So it is nothing but 5 into 9 or nothing but 45 ohm plus. Simple. So that will be the value of R2 dash. What will be? That will be the value of R2 dash. Okay. And see, it is changed to secondary winding. That I told you, no? So small confusion in the question, that confusion gone. So it is changed, please change it to secondary winding having a reactance of 3 ohm. Okay. So what will be the reactance referred to primary? Reactance referred to primary. This is nothing but X2 dash, which is nothing but old X2 into, in which direction or which side it is coming? It is coming to N1 side, right? So it will become N1 by N2, again the whole square, which is nothing but X2 is given 3, right? 3 into 3 square, which is nothing but 27 ohm, correct? 9 into 3, 27 ohm. So this is nothing but X2 dash. Bas, that is the answer. That is the answer. That is the answer. Okay. So that's all about the question. It's very easy, right? It's very, very easy. But the conversion, no, you have to take care. See, in many textbook, no, so they may represent like A, K, etc. and by K square, into K square. That type of confusion is there. Actually, whenever we are doing calculation, open circuit and short circuit test in transformer, in your laboratory, you may feel the same problem there. You have to multiply it with the K square or divide with the K square, and what is the value of K? whether it is high voltage by low voltage or low voltage by high voltage, all confusions will be there, and you have to simply by heart and mug up and go to exam, right? That is the normal thing you are doing in your laboratory now. So now this confusion is over, right? Now the confusion is over, right? So that's all about that question. Let's move to another question. Okay, let's move to another question. Write a question. In a 440 bar 220 volt step down transformer if primary winding resistance is 9 ohm, resistance is 9 ohm and reactance is 5 ohm. Full stop. Calculate both value referred to secondary. That's also very easy question. Very easy question, but you have to check the basic knowledge, right? You have to check the basic knowledge. In a 440 bar 220 volt step down transformer, of course the parameter itself, we got an idea that it is a step down transformer, right? So it will be what? N1 by N2 will be what? Simply N1 is nothing but primary number of turns. N2 is nothing but secondary number of turns or voltage, right? So it will be 2, simply 2, right? Simply 2. So that is N1 by N2 is equal to 2. If the primary winding resistance is 9 ohm, primary winding resistance means R1 equal to what? 9 ohm, and primary winding reactance is nothing but 5 ohm. It is given in the question, right? It's given in the question. And we have to find both the value referred to secondary side, right? Both the value referred to secondary side. Secondary side is nothing but it will become dash. When R1 go to that side mean it will become dash. When R2 go to this side mean it will be again R2 dash, right? When R1 go to that side means it will like R1 dash. So R1 dash is nothing but what? Old value of R1 into where it is going? It is going to M2, right? Secondary side, right? So numerator will be what? The secondary number of turns, the whole square. That is the difference. So it will become simply what? It will become simply, what is R1? It is 9, but is N2 by N1. N1 by N2 is 2 na? So N2 by N1 will be 1 by 2, the whole square, which is nothing but 9 by 4, which is 9 by 4. Nothing but 9 by 4, right? 9 by 4. Okay? And what will be x1 dash, right? Because reactance also you have to make it to what? To primary side, right? Resistance and reactance is 5 ohm, right? Calculate both value referred to secondary, right? So that reactance here also going to secondary side. So to what side it is going? N2 side is going, right? So it will become x1 dash equal to old x1 into again N2 by N1 whole square. Old x1 is nothing but 5 into N2 by again 1 by 4, correct? So it is simply 5 by 4. So that is the answer. Simple. Very easy. Very easy problem, right? Very easy problem. Okay? Is it correct? Okay. Write another question. Through questions we are learning so many things, right? At 25 kVA, (2200) bar 220 volt 50 hertz single phase transformer has the following resistance and simply following parameter, right? You know this, right? No need to write resistance and leakage reactances. R1 equal to 0.8 ohm, R2 equal to 0.009 ohm, X1 equal to 3.2 ohm, X2 equal to 0.03 ohm. Calculate A equivalent resistance referred to primary. B equivalent reactance referred to primary. C equivalent resistance referred to secondary. D equivalent reactance referred to secondary. Yes, that's our question. That's our question. That's our question. How can we do this? How can we do this? You have all the parameter, right? You have all the parameter. A 25 kVA, 25 kVA means it's volt-ampere rating, right? 2200, right? So it would be N1 by N2 will be 2200 by 220, right? So it will become 10, right? 10. It will become 10. So first you have to find what? Equivalent resistance referred to, right? Equivalent resistance referred to primary. So in the primary side, what will be the normal resistance? In the primary side alone, there is a resistance of what? R1, right? And in the secondary side, there is a resistance of R2. You have to transfer that resistance from secondary to primary so that it will become R2 dash. If you add these two primary together, you will get equivalent resistance referred to primary, which is nothing but R1E or R equivalent dash, or any parameter you can use, any abbreviation you can use. No, I refer like R1E or R1 equivalent. With R1 is nothing but referred to primary. R resistance 1 primary side, E equivalent. So R1E is nothing but equivalent resistance referred to primary, right? So what will be the value? R1 is given, right? 0.8. R2 dash, what is R2 dash here? R2 dash is nothing but secondary to primary you are coming, right? So to what side you are coming? You are coming to first primary side. So it will become the old R2 into N1 by N2 the whole square, correct? So it will become 0.8 plus old R2 is what? 0.009 into N1 by N2. What is that N1 by N2? It is 10, right? So it will become 100. So it will become 0.8 plus 0.009 into 100 means simply 0.9. So 1.7 ohm. 1.7 ohm, right? So that is R1 equivalent, R1E. And next B, what is that? Equivalent reactance referred to primary side. Equivalent reactance referred to primary side means initially there are some equivalent reactance, let be X1 in the primary. So from that secondary side reactance you have to transfer to primary side. So it will become X2 dash. If you add this together in the primary, no? So now in the primary there are one reactance, one that transferred reactance is also there, right? So it will become total X1E. So X1E is nothing but equivalent reactance referred to primary plus. So it will become X1. What is X1? 3.2 plus X2 dash is nothing but X2 into what area you are coming? To N1 side you are coming, right? So N1 by N2 the whole square. See how easy this problem is, right? If you know the concept, it's very easy. 0.03 into 100. N1 by N2 the whole square is nothing but 100. So 3.2 plus 0.03 into 100 means simply 3, right? Simply 3. So 6.2. So 6.2, right? 6.2. Add it. Next. What is our C session? Equivalent resistance referred to secondary, right? So equivalent resistance referred to secondary means, so initially in secondary there are some resistance which is nothing but R2. There are some resistance which is nothing but R2. And you are transferring the primary to secondary, right? The primary resistance to secondary side. Then only it will become equivalent resistance referred to secondary. So you are converting the primary side resistance R1 to the secondary side means it will become R1 dash. That is nothing but R2E. That is nothing but equivalent resistance referred to secondary bus. So what will be your answer? R1 dash is nothing but old R1 into to what area you are going? You are going to secondary side, right? So secondary side number of turns the whole square plus R2 is old R2 is nothing but 0.09. So it will become R1 is nothing but 0.8 into N2 by N1 is nothing but 1 by 100, right? 1 by 100 because N1 by N2 is 10, right? So it is 1 by 100 plus 0.00. So it will become 0.008, right? Plus 0.009. 0.017. Is it clear? Is it clear? Similarly, you can solve for that D session also. You can solve for that D session also. What was our D? Equivalent reactance referred to secondary. So initially in secondary there was a reactance X2, and from primary side you are converting the primary side reactance to secondary side. So it will become X1 dash. So the effective will be X2E, X2 equivalent. See the abbreviations, right? You can give any value, any abbreviation. So you can give Anil, it's my name, right? You can give Anil, you can give Sunil, you can give anything, any value, right? You can give any value, no issues. The answer should be same. That's our aim, right? The answer should be same. That's our aim. That's our aim. So this is okay. So it will become X1 dash plus X2, right? So what is the answer, beta? What is the answer? It will become X1 dash is nothing but old X1 into to what side you are going? You are going to secondary side. So the numerator will be N2, right? The whole square plus X2. So it will become X1 into 3.2, right? 3.2 into N2 by N1 is again 100, 1 by 100 plus X2 is nothing but 0.03. So it will become 0.032 plus 0.03. So the answer will be what? 0.062. 0.062. So that's all about the problem. That's all about the problem. See, the problem is very easy actually, but you have to know the conversion technique. Unless if you know this concept, it's very difficult. If you don't know this conversion technique, actually I will call it as a technique because it's perfect technique for converting any value to any other side. See, I was also very much confused when I was in BTech. At that time also, simply I mug up something and go to the laboratory. I exactly didn't know what is the meaning of that conversion and all. But no, later, after that, I studied myself and found out some trick. That's it. That's it. This is not my trick. My sir also gave me. After that, I did some online classes and all. And from that, a sir told this trick. It's not my trick. Okay, it's not my trick. I don't want to take the credit. Okay, so it's not my trick. So someone told me, and I'm giving to you also. Right? It's a wonderful trick. That's why it's a wonderful trick. Okay, so that's all about the concept. So let's go to next problem. Okay, write a question, my dears. Write again a question. Write again a question. So what is the time now? What is the time now? Time is there. Time is there. 2 transformer of, it's a big question actually, but the answer is very easy. Let's try. 2 transformer of same grade of iron. Of same grade of iron and conducting material. And conducting material. Both are designed for same flux density. Both are designed for same flux density, same frequency and same current density. And same current density. Full stop. The linear dimensions of second transformer is the linear dimension of second transformer is double as that of the first. Double as that of the first. Find the ratio of volt ampere rating of both transformers. Oh, what a big question. What a big question. What a big question. What a big question is. How can we do this? 2 transformer of same grade of iron, which means same quality of iron, and conducting material. That means the number, conductors also. Copper means other one also copper, right? In first one is copper means other one also copper. That is the meaning of same conducting material. Both are designed for same flux density. Both are designed for same flux density. Let B1 is the flux density in the first one and B2 is the flux density in the second one. Plus B1 equal to B2. Same frequency F1 equal to F2. Same current density J1 equal to J2. The linear dimension of second transformer is, linear dimensions means nothing but transformer having a length and a width, right? Transformer having a length and a width. Thus, length into width will give you the value of cross sectional area. So, the linear dimension of second is double as that of the first means let the width of the second is nothing but W2, it will be double of the first one. The length of the second is L2, which will be double of the first one. So that A2 will be equal to 4 times A1. Am I right? Because area is nothing but width into length, right? So W2 into L2 is nothing but area of second one. So A2, which is equal to 2 into 2, 4 times W1 into L1 is nothing but A1. So A2 is equal to 4A1. Initial itself you will get the relation. The linear dimension of second is double as that of first. Find the ratio of volt ampere rating of both the transformers, which means we have to find V1 I1 by V2 I2. That is the meaning of volt ampere rating of first and second transformer. How can we start? How can we start? So that we have the value of V1 first, we have the value of V1 first, we have the value of I1 also, we have the value of V2 and we have the value of I2. Okay, how can we start at least? How can we start from? How can we start from? Think. From where we can start for this question? Listen my dears, listen. We have the basic equation of transformer as, let be for first transformer, V1 equal to what? 4.44 into F into phi m into N1, correct? For first transform, right? Let be F1, let be phi m1, etc. And for second transformer, you can write like 4.44 into F2 into phi m2 into N2. For same conductor material means this is same, N1 and N2 are same. For same frequency means V2 is equal to 4.44, F2 into what, phi m2. So F1 and M2 are same also, here also it's equal. So I can write like V1 proportional to, because all are constant, right? V1 proportional to phi m1, because same flux density is, see, both are designed for same flux density. Flux density is nothing but Bm, not a flux, right? And V2 proportional to phi m2, right? Phi m2. But phi m can be write like Bm1 into A1, correct? And phi 2 can be write like Bm2 into A2. Am I right? They are given same flux density. So simply V1 proportional to A1, because Bm1 and Bm2 are equal, and V2 proportional to A2. Very important conclusion. Very important conclusion. My dears, very important conclusion. So V1 by V2 will be equal to what? A1 by A2. But initially you found something, A2 is equal to 4A1, so A1 by 4A1, so it will be equal to V1 by V2 equal to 1 by 4. Very important relation. V1 by V2 equal to 1 by 4, or simply V2 equal to 4V1. That also you can write. V2 equal to 4V1. So you got the relationship with V2 and V1. So you can substitute that V2 and V1, you can something do from this V1 and V2 side, right? But what for I1 and I2? What for I1 and I2? For that there is another clue. What is that? Same current density. See the term, same current density. That means J1 will be equal to what? J2. J is nothing but, yes, I1 by A1 equal to I2 by A2. Bas. So I1 by I2 will be equal to A1 by A2, or simply A1 by 4A1, or I can write like I1 by I2 equal to 1 by 4, or simply I2 equal to 4I1. Another relation. So now you have the relations of current also. So you have voltameter rating even I1 by V2 I2 equal to what? This is the ratio, right? This is the ratio we have to find, right? So V1 by V2 is nothing but 1 by 4 into what is I1 by I2? It is again 1 by 4. So the answer is 1 by 16. So VA rating ratio is nothing but 1:16. 1:16. That is the final answer. That is the final answer. Did you get my dears? Did you get the idea? Did you get the idea? Okay. Did you get the idea? Okay. Write another question. It's very easy, but the concept is very important. Feel the subject and study, please. It's my request. For machine especially. No, circuit theory there is a limitation for feeling and study, but machine you can feel, you can imagine. You are in a machine, you are in primary side, you are in secondary side, you can imagine like that. So let's do a final question. Okay. Write a question. Okay. If a transformer of 400 watt 400 bar 200 volt 50 hertz single phase, find the value of RL for maximum power transfer to load. Beautiful question. This is also a very beautiful question. If a transformer of 400 bar 200 volt means simply N1 by N2 is equal to what? N1 by N2 is nothing but 400 by 200, nothing 2, right? Find the value of RL for maximum power transfer to load, which means you have to find the value of RL such that maximum power transfer should be there. For maximum power transfer, my dears, what was the condition? For maximum power transfer, RL will be equal to what? R Thevenin. Here the R Thevenin is nothing but, only this resistance is there, right? There is no indication of any resistance, any other resistance, but this is electrically isolated. So you have to make this 10 to here, and if this and this will be equal, then only maximum power transfer will happen. So what is the equivalent resistance referred to load side, which is nothing but 10 into to what direction it's moving? To secondary it's moving, right? N2 by N1 the whole square. So 10 into what is N2 by N1? It is 1 by 2. So 1 by 4. So 10 by 4 or nothing but 2.5, right? 5 by 2 is 2.5. So this is the answer. If you convert this 10 to secondary side is the load, right? This is the load. So there will be a resistance like this, and that is nothing but R1 dash. If R1 dash equal to RL, maximum power transfer will happen. So the value of RL for maximum power transfer is equal to what? 2.5 ohm. Plus that is the answer. Kadam Kali. How beautiful the question and how beautiful the answer is. You have to think and write. Right? Okay. So that's all about the question. So that's all for today, and let's meet again tomorrow with a new session. Okay. Thank you.